we're going to focus on solving polynomial inequalities. So let's start with this example. Let's say if we have x squared plus 3x, let's say it's greater than 10. What's the solution? Now, when you have an equation, x is going to equal a specific answer, an exact answer. But when you're dealing with inequalities, x can be a range of answers. The first thing you should do is move the 10 to the other side. What we have is a quadratic inequality. And then we need to factor. What two numbers multiply to negative 10 but add to 3? So this is going to be 5 and 2, but 5 and negative 2. 5 plus negative 2 is positive 3. So it's going to be x plus 5 times x minus 2. Now, what we need to do at this point is make a number line. The points of interest are 2, because if you plug in 2, you get 0. And here, negative 5. If you set x plus 5 equal to 0, x is equal to negative 5. Now, notice that this expression is greater than 0, not greater than or equal to 0. So therefore, negative 5 and 2 will not be included in the answer. So I'm going to put an open circle as opposed to a closed circle at those points. Now, all the way to the left, we have negative infinity. All the way to the right, we have positive infinity. Now, there's 3 boundaries of interest. This is the first region, the second, and the third. Now, the product of these two factors has to be positive, greater than 0. So we got to see which of these 3 regions is positive and which one is negative. So let's start with this region. Let's pick a number that's between 2 and infinity. Let's try 3. Now, 3 plus 5 is positive, and 3 minus 2 is also positive. When you multiply 2 positive numbers together, you're going to get a positive result. Now, let's pick a number between negative 5 and 2. Let's try 0. 0 plus 5 is a positive number. 0 minus 2 is negative. A positive times a negative number will give us a negative number. So it's negative in this region. Now, let's try negative 6. So negative 6 plus 5 is negative. Negative 6 minus 2 is negative. When you multiply 2 negative numbers, it will give you a positive number. So because it's greater than 0 and not less than 0, we want the part where x plus 5 times x minus 2 is positive. So we want this region on the left and the region on the right. So to express the answer using interval notation, it's going to be from negative infinity to negative 5, not including negative 5, union 2 to infinity. Now, if you wish to express your answer as an inequality, you could say that x is greater than 2, that corresponds to this part, or x is less than negative 5, which corresponds to that part. So you can describe your answer using interval notation or using inequalities. So that's it for this problem. Let's try another example. X cubed minus x, and let's say it's less than or equal to 3x squared minus 3. So go ahead and solve this particular polynomial inequality. So what I'm going to do is I'm going to take everything from the right side and move it to the left side. And make sure you write it in standard order or standard form. So it's going to be x cubed minus 3x squared minus x plus 3. And that's less than or equal to 0. Now, we need to factor by grouping. So let's take out the greatest common factor in the first two terms, which is going to be x squared. And so x cubed divided by x squared is x. Negative 3x squared divided by x squared is negative 3. Now, in the last two terms, let's take out a negative 1. So then this is going to be x minus 3. Now we can also factor the GCF at this step. We can take out x minus 3. So if we take out x minus 3 from the first term, we're going to have x squared left over. And if we take it out from the second term, we're going to get negative 1. Now we can factor x. So if we take out x minus 3 from the first term, we're going to have x squared left over. And if we take it out from the second term, we're going to get negative 1. Now we can factor x squared minus 1 using the difference of perfect squares. It's going to be x plus 1 times x minus 1. So now let's create the number line. So there's 3 points of interest. So we have negative 1, 1, and 3. And then to the right we have positive infinity and negative infinity on the left. Now, notice that it's less than or equal to 0. Because of the underline, it's going to include these 3 points, negative 1, 1, and 3. So I'm going to use a closed circle as opposed to an open circle this time. So now, we need to make sure that it's less than 0 or negative. So we don't want the regions where it's positive. Let's test the signs. So let's start with 4. That's between 3 and infinity. So 4 minus 3 is positive. 4 plus 1 is positive. 4 minus 1 is positive. So if we multiply 3 positive numbers, that will give us a positive result. Now let's pick a number between 1 and 3. So let's try 2. So 2 minus 3 is negative. 2 plus 1 is positive. 2 minus 1 is positive. So these 3 signs, when multiplied together, will give us a negative number. And the signs will alternate because the multiplicities of each 0 is 1. So the next one should be positive. So let's pick a number between negative 1 and 1. Let's try 0. 0 minus 3 is negative. 0 plus 1 is positive. 0 minus 1 is negative. 2 negative numbers will make a positive result. And the last one should be negative. So if we try negative 2, negative 2 minus 3 is negative. Negative 2 plus 1 is negative. Negative 2 minus 1 is negative. The net result is negative. Now we want the part that's negative, so we want this region and also the region between these two parts. So the answer is going to be from negative infinity to negative 1, but including negative 1, so we need to use brackets instead of parentheses, and then from 1 to 3. So that's the answer using interval notation. Now what's the answer using inequalities? So for the first part, we could say that x is less than or equal to negative 1. So that covers this region. And then for the second part, we could say that x is less than or equal to 3, but greater than or equal to 1.